All right, let's do some Mathity-Math. It says, find the resultant of each of the vector sums and find the magnitude and the direction. And we're going to assume an angle that is anti-clockwise or counterclockwise from the direction of I. Okay, we can handle that. So when we look at this, they're in column form. This is, if you look at it, you could say that these top numbers right here, these are your I's. Okay, we can call those the I's. And these bottom numbers are the J's. That's another way you could also say these are just my X coordinates and these are my Y coordinates. But in essence, we just add the tops and then we just add the bottoms. So let's just do that first. Okay. So here we go. 1 plus -1, well, that goes away. There's nothing left. 1 plus -1 is 0. And then we get up here, we just get 5. Okay? And let's see here. 4 plus 3 is 7. And then plus -2, well, that's like saying -2. So we have 7 minus 2. Well, that is 5. Okay, so we have 5 over 5. Okay, I think we can handle that. Okay. So at this point, what we essentially know is we know where our resultant vector ends. It's going to end over 5 on the x-axis and then up 5 on the y-axis. So it wants us to find the magnitude and it wants us to find the direction. So I think we should go ahead and tackle the magnitude first. And we can tackle the magnitude in a pretty straightforward fashion. I'll draw a quick sketch here to help us really visualize it. And I always encourage everyone to go ahead and draw like a little picture. It helps. And some of us are visual learners, so why not help yourself learn? Okay? So we go over 5 and we go up 5. So that resultant would end up like that. And if you see that, that creates a nice little right triangle. And that right triangle is a 5 on the x and a 5 on the y. So to find the magnitude of this resultant vector, we just use the Pythagorean theorem. And because this one went over 5, that means one leg is 5 and it goes up 5. So the other leg is 5, and then we're going to find the hypotenuse. And we do that, because this is a right triangle, using the Pythagorean theorem. So we say a squared plus b squared is c squared. Okay, and we know this x is 5, so that's 5 squared. And we know this y is 5, well, that's 5 squared. And we get c squared. That's going to tell us that it's 25 plus 25 is c squared. I'm going to scooch on down here so we can see better. And then that just says 50 is c squared. Next step, we take the square root of both sides. So I'll show this. Square root of 50 equals, it's going to be the square root of c squared. So those we're going to cancel. We'll get left with just c. So then we're going to say c is, and I don't know what the square root of 50 is, but I can check right here. So square root of 50 is, we'll say 7.07. Okay, so now we have our magnitude. We know our magnitude is 7.07. Great, we're halfway home. We found our magnitude. But now they also say they want us to find that angle direction. So what they're specifically saying is they want to know, because it says assume an angle that is counterclockwise or anti-clockwise from the direction of I. So we know our I traveled out this way, so we're going to go back up this way, counterclockwise, like it said. And I said, well, what is that angle? What's that angle right there? What is that theta? Well, we can do this. And all we really need here is to use a little bit of trigonometry. And a good clue that you need to use trigonometry is it is a right triangle. So we'll just use that right triangle trigonometry. SOHCAHTOA. Quick reminder, SOHCAHTOA, we say sine is opposite over hypotenuse. Right? Cosine is adjacent over hypotenuse. Right? And tangent is opposite over adjacent. So if we had to mark off these sides on our little sketch diagram here, if we're here, well, this resultant, this is our hypotenuse, okay? And because we go directly opposite, well, this side would be our opposite, And then down here, if it's not hypotenuse, it's not opposite, well, then it must be adjacent. Okay. So what we're going to do here is we're going to look at these values and see if we can find both values and make one of these work. So sine, we said opposite. Well, opposite is 5. We know that. But we don't know hypotenuse, so we're not going to use that one. Cosine, well, we know adjacent is 5. But again, we don't know the hypotenuse. Tangent, opposite of adjacent, we know that. We know it's 5 over 5. So because we're trying to solve for the angle, essentially we get into the situation where we're saying tangent, and then of the angle that we don't know, we call that theta, would be 5 over 5. You could also call that 1, because 5 divided by 5 is 1. But in this situation, when we're trying to find the angle, we actually need to use the inverse of tangent. And the way we use the inverse of tangent, on your calculator, it just looks like this. Tangent, and then to the inverse. And what that will do, it will give us the value of that angle. So we're going to do 5 over 5. So just go to your calculator and just hit your I guess I can show you guys, right? Let's see here. You just hit your second key, like that, and you go to tangent, but because I hit the second key, now it's my inverse tangent, and then you can see inverse tangent, and I'm just saying 5 over 5, and I guess I could have said 1 if I wanted to. So I did tangent, 5 over 5, and hit enter. And it says 45, and that actually makes perfect sense because the two legs are the same, so it must be a 45-degree triangle. And so that thing is 45 degrees. So we know that this value for theta would be 45 degrees. It would turn up 45 degrees, just like that. One last word of warning. Please, please, please make sure your calculator always is in degree mode when you're using degrees. That's how you make sure you get the right answer. And I hope this helped. If you want to be alerted when I make new videos, don't forget to subscribe. And also, if there's a special problem you would like to see, please let me know in the comments below, and I'll do my best to make that problem for you. Bye.